So in this video we'll be covering how to plot quadratic equations. Now the key thing to note in this is different to sketching quadratic equations. So this is where we'll be accurately plotting a quadratic equation using a table of values, and we'll also be talking about key things you need to remember and common mistakes that can be made. Now the important thing to note that when you are asked to sketch an equation, that you should be able to recognise what type of graph or what type of line or curve it's going to be without actually physically having to draw it. So when it comes to sketching quadratics, if an equation of a line or a curve whereby the highest power of x in the equation is x squared, then we can class it as being quadratic. So for example, as you can see on your screen, we've got several equations of a line or a curve, and we can actually identify what type of graph it's going to be without physically having to draw it accurately. So in this first one of y equals 3, we know that when an equation's just got y equals a number, then that is going to produce a horizontal line. And that's actually going to go through 3. So it goes through 3 on the y-axis. Now when we've got an equation that involves a single x and a single y, then that's going to be a diagonal line. And as it's got a positive gradient, it's going to be going upwards. Now here we can see that we've got x equals -4, so that's going to be a vertical line, and that's going to go through I've got the h there, and that goes through -4. So we'll close the bracket there. So that goes through -4. So that's going to be a vertical line, whereas this one's going to be a horizontal line. Y equals 2x minus 5, again that's going to be a diagonal line because it's got both a single x and a single y, and as it's got a positive gradient it's going to be going up. For y equals 10 minus x squared, now because we've got x squared, that's going to be a quadratic because the highest power of x is x is 2. And this one here again, we've got x squared, so that's going to be a quadratic. Here we've got, again, y equals x squared, that's also going to be a quadratic. Now for y equals x squared minus 4x, now here we've got an x squared and we've got x, but the highest power of x is 2, so therefore that one is going to be quadratic. And for y equals 6 minus 5x minus 6x squared, well again, we've got x, we've got a number, and we've got x squared, but the highest power of x is x squared, so that's also going to be quadratic. And then for this one here, we've got x squared, but we've also got x cubed, so because x squared isn't the highest power of x, x cubed is, that's what we're going to call not what we're going to call, it's what's called a cubic graph, or a cubic equation. So any equation where the highest power of x, or you can see an x squared and that's the highest power of x you've got, it's going to be a quadratic. So let's move on to the next part. So recognising the shape of a quadratic equation when it's plotted. So if a quadratic equation is plotted, then the shape of the curve is what we call a parabola. I know some students call it a parabola, but it's actually called parabola. But then tomato, as long as it's not a speaking exam. But it's actually called parabola. And produces either a U shape or an N shape, what we call. And the shape is based on the sine of x squared. So if we've got a positive x squared in our equation, then it's basically going to produce a U shape, like so. Now the U shape could be anything. It could be like here. It doesn't necessarily have to cross the x-axis. It can either touch it. It doesn't matter what quadrant it's going to be. So I could have one that goes over here. I could have one that goes over on this side. But as long as it's a U shape, then that's fine. And what we tend to call a way of remembering this is, if you're feeling positive, you are feeling happy. And again, if you look at the mouth, it's a U shape, and we go from there. And if your x squared is negative, then it's going to be what we call an N shape. So I just label these axes because again, it's very good practice for you to label your axes, and that's going to produce what we call an N shape. And again, it doesn't really matter how many times or what quadrant that N shape is going to be. it could cross the x-axis at one point, it could cross it at no points. It doesn't really matter. But basically it's just going to produce an N shape. And again, if you're feeling negative, then what we say, it's a sad face. So again, representing the mouth with an N shape, and we go from there. So it's always important that you recognise this, so that when you're actually plotting, this is where we use that common sense of recognising what your graph should look like, or what your answer should look like, before you actually do it. So when you get your answer, you could then think to yourself, yep, that looks about right, or I've definitely made a mistake. So let's have a look at the next part. So again, it's important you recognise these in terms of the shapes. So in this particular 6 questions, or 6 equations I should say, what we want to do is just recognise the shape of the parabolas. So they're all quadratics because the highest power of x is a 2, or we've got an x squared in there. And so all we're doing is deciding whether it's going to be a positive parabola, so a U shape, or it's going to be a negative parabola, an N shape. So looking at the first one, you can see that the x squared is positive, so that's going to be a U shape, or a positive parabola. For question 2, again, my x squared is positive, so even though it's 3x squared, it's still positive 3x squared, so that's going to be a U shape, and again, that's a positive parabola. For question 3, you can see here that we've got a negative x squared, so that's going to be an N shape, and that's what we call a negative parabola. For question 4, again, we're looking at just the x squared, so not the constant, so not the number, not the x's, we've got just the x squared. So the x squared in this case again is positive, so it's a U shape, and again that's a positive parabola. And for question 5, again we've got a minus x squared, so that's going to be an N shape, and that's a negative parabola. And again, lastly for question 6, we've got a positive x squared, so that's going to be a U shape, or it's more mathematical word of a positive parabola. So let's have a look at the next section. So the next thing we come across is plotting. So when plotting any line or curve from its equation, we need coordinates. So with a quadratic equation being a curve, we need a series of coordinates to help us plot the equation correctly. So if you imagine like a straight line, then the maximum number of, or the minimum number of coordinates I should say, are going to be 2. Now hopefully your teacher or revision guides or whoever's taught you how to plot straight line graphs kind of focuses you to do 3 just to make sure you've not made a mistake, and all those 3 points should form to make a perfect line. Now when you've got a curve, having 1 or 2 points is not going to be enough, because it can distort where the ends of that curve are going to go. So it's always important that you have a series of coordinates. So the question is, how many coordinates do we need? Well, this is where some guidance will be given to you. So guidance will be given in the question, or they might give you what we call a table of values. So the best way of doing this is by using a table of values. So this is where you are given specific x ordinates and use these to find their respective y ordinates. Again, I just found a spelling mistake, so let's just correct that. So to find their respective y ordinates in an exam, this will most likely be given to you. However, for classwork and homework, you may need to draw this yourself. So for example, it's just a case of a table of values would always be given to you, and I can see that spelled there wrong, so let's just correct that. Tell you what, let's record this again. So when plotting any line or curve from its equation, we need coordinates. Now with a quadratic equation being a curve, we need a series of coordinates to help us plot the equation correctly, and the best way of doing this is by using a table of values. Now in the past you may have only been drawing straight lines on graphs, and to draw a straight line the minimum number of points you need is going to be 2. Now hopefully your teacher would have told you to always make sure using maybe 3 or 4 just to make sure that you've not made a mistake. And if you're using more than let's say 3 coordinates, then it's going to be pretty evident if you have made a mistake, because obviously those 3 points should form to make a perfect line. Now when you've got a curve, having 3 coordinates is not going to be helpful, because those 3 coordinates could, one, be very very close together, And again, as we've shown, that it's going to produce a U shape, so you kind of need a series of points to give you that U shape or that N shape on your graph. Now this is where we're given, now table of values, this is where we're given specific X coordinates to use, and we need to find their respective Y ordinates. So in the exam you'll be given this to you, however in classwork or homework you may need to draw this yourself. And again we'll go through some examples of what that's going to be like. Now for this you are going to need your calculators, so if you have a look at the very first one, so example 1 says by completing the table of values plot y equals x squared plus 3. So this is our equation of a line. So here is, so we just highlight that. So this is what we're plotting. Now straight away I know that from this equation that it's quadratic. How do I know it's quadratic? Because the highest power of x is x squared. And I also know that my x, as my x squared is positive, it's going to be a U shape. So I've already got an idea of what my graph should look like. So it's going to be a U shape, and it's going to be quadratic as a parabola. Now, when filling in these, so I'm going to be using the x ordinates of -3, -2, 1, 0, 1, 2, 3. And what I need to do is I need to find out the respective y ordinates. Now, if I write down the equation again, just slightly bigger, and I put a bracket around the x, what I'm going to be doing is I'm going to be swapping x in the equation with these x numbers in the table. And the answers I'm going to write in the y box that's just underneath it. So for this value here, let me just get a different colour pen. So for this box here, I'm going to use y equals, I'm going to put a bracket, -3 squared plus 3. Now you might want to enter this on your calculator, although that can be quite fiddly. And if you are going to enter this on your calculator, make sure you're using brackets, because certain calculators don't like negative numbers. Now, or you can do this in your head depending on how easy the equation is. So here I've got -3 squared is 9, plus 3 is going to be 12. And then if I move on to the next coordinate, so here I'm going to have y equals, and then it's -2 in brackets squared plus 3. Now -2 squared is 4, plus 3 is 7. And then I just repeat the process. So here I'm going to have -1 squared plus 3. So -1 squared is 1, plus 3 is 4. Now again, you don't have to be writing this down. You can do this in your head, but just make sure it's correct. For the next one, I'm going to have 0 squared plus 3, which is just 3. And using a different colour pen, I don't know how nice it's going to show up, I've got 1 squared plus 3, and again, put in brackets, which is 4. And then I've got, running out of colours, let's go for black. So here I've got 2 squared plus 3, which is 7. Let's just rub that out. And that looks like 17. So I've got 2 squared plus 3, which is 7. And then finally, I've got 3 squared plus 3, which is 12. Now what I've got in that is I've got my coordinates. So one coordinate is going to be -3, 12. The next coordinate is -2, 7. The next coordinate is -1, 4. The next coordinate is 0, 3. And 1, 4, 2, 7, and 3, 12. Now, one of the most difficult things, so that's us completing our table of values. Now, in an exam, generally speaking, because this is quite a time-consuming task, what you'll find is that you only have to find 1 or 2 y ordinates. So you only have to do the calculation, maybe 1 or 2, maybe at most push 3, but then you'll get 3 marks for it. Now it's important that we've actually found our coordinates, and that's absolutely fine. The next thing is that we won't move on to is drawing the graph. Now, drawing the graph again is one of the most frustrating, and I know students tend to find this frustrating, and it's knowing, the question I get asked as a teacher is, what scale do I use? Well, the difference is it's just using our common sense. So in terms of our axis, so I'll just draw it on the screen. We've got our x-axis going across and our y-axis going up. Now for this, my smallest x ordinate is -3. So I need to go -3 is my lowest value, and the biggest value I've got is +3. So I need to go 3 going there. So the range of x values I've got are -3 to 3. Now if I look on the bottom row, I don't want to go from 12 to 12 because that's just the same number, but you want to look at what's your biggest number. In this case it's 12. Now for your y values I'd go slightly higher, and it's always good practice to go that little bit higher. And then for my smallest value is 3, which again I'm going to have 0, so that's going to be fine. So actually, because it's unlikely I'm going to have any negative values, I can kind of just have my graph so it looks like that. And again, I'm just going to put a bubble around it. So, and again, when plotting graphs, it's all about accuracy. So you want to make sure that you're using graph paper, or at least squared paper. You want to make sure you're using a ruler and a pencil, and making sure that your numbers are equally spaced. So from using those coordinates, what we then want to do is plot this accurately. Now, although the graph is actually drawn, I've used the software to do it, the key thing is knowing how to plot the points. Now, some people, when they're marking coordinates, mark it with a little x. Some people mark it with a little dot. It doesn't really matter which, as long as it's neat and doesn't completely take over the graph, then that's absolutely fine. I'm a bit of a stickler for a point, just because it's easy. And then the next thing that a lot of students tend to struggle with is joining the points up. Now, one thing you don't want to do is join the coordinates up with a ruler and leave that as your final answer. It's supposed a quadratic curve is supposed to be smooth, and if you're drawing a quadratic curve with a ruler, it's definitely not going to be smooth. Now, one thing that students tend to struggle with is connecting those points up. And if you draw it freehand, like for example, if I do a rather failed attempt at connecting all of those points on, well, it started okay in the middle, but as you can see, that's not great. And it's a prime example. For starters, I could lose marks, even though I've plotted the coordinates correctly. The fact that I've completely missed that one there, and this one here, and also that one there, you can see that I'm going to lose some marks in terms of accuracy. So one thing you might want to do is to lightly, with a ruler, join the points up. So you've just got a series of straight lines like so, and then going over those lines to make it more of a smooth edge like so. And as long as your line goes through the points, that should be good enough to get the marks. Now, if you're also drawing your set of axes and the graph's not been drawn for you, make sure the numbers are equally spaced and you're starting from 0 and the origin. Your numbers are equally spaced on the y-axis, numbers are equally spaced on the x-axis, and also that you have labelled your axes. And these are key errors where a lot of students tend to make, because they just think, oh, just plot the coordinates and that's it. There are also cases where students have not plotted the line, so they've plotted the coordinates but they've not connected the coordinates up with that smooth curve. And if you just left it as like a dot to dot, you're going to lose a mark in an exam for doing that. So make sure that not only you're plotting the coordinates correctly, that you're also taking the time to join them up as well. Now, the other key thing is when you are plotting the coordinates. Now, although I can't get rid of the red line there, one thing that is good about plotting the coordinates and you having the coordinates is, let's say I'm plotting these points here. Now, let's just say, for argument's sake, that I've made a mistake in my table. Now, as you can see, because the original equation was y equals x squared plus 3, and we knew that that's a quadratic, but it's also going to be a U shape, and a smooth U shape, it should ring alarm bells, and using my common sense should tell me that this point here is wrong. So either I've made a mistake in plotting the coordinates, so either I've got the x and y coordinates muddled up, or that I've made a mistake in the actual calculation in my table. And so it's clear to me that I've definitely made a mistake, and the last thing I'm going to do is leave my answer like that, because it's clear I've definitely made a mistake. I'm not going to get any extra marks just by plotting incorrect coordinates, so it's important that I go back and I check that this mark is wrong. And again, using your common sense, well, I can kind of guess where that point should be, because it should be there. So even if I was to go back to my table of values and change that, let's say that 7 into a 4, then that's going to be absolutely fine. So the little tweaks that you can do in your graph to make sure that you're doing it, again, it's all about neatness, taking your time, not too much time obviously, but making sure you have done this correctly. So let's have a look at another question. So this time we've got a negative quadratic. So first things first, I can see, looking at the equation, I can see that it's not only is it a quadratic, but my x squared is negative, so it's going to be a sort of N shape or sad face. So working through the coordinates. Now in an exam, this is typically what your question would generally look like, because it's not asking me to do all the values, it's just asking me to do some. So again, if I write down the equations, I've got 10 minus x, and I'm going to put that in brackets squared. Now all I'm going to do is I'm going to swap this x in my equation with these values here, and in particular I don't have to do all of them because some of them are done for me. The only ones I need to do are for minus 2, 0, 1 and 3. So let's have a look at doing this. Now if I was doing this on a calculator, which I'll show you how to enter this on a calculator as well, then I'd set the calculator just like this. However, because the equation is relatively quite simple, I should be okay doing this in my head. So I've got 10 minus, and then it's minus 2 squared. Now minus 2 squared, minus 2 times minus 2 is positive 4, so that's 10 take away 4, which is 6. And then for this one here, I've got 10 take away 0 squared, which is just 10. And then I've got 10 take away 1 squared, which is 9, and 10 take away 3 squared gives me 10 take away 9, which equals 1. Now one thing you should be able to spot from what you can see on the screen is that the y values are actually mirrored. They kind of start repeating themselves. Now you might think that this is perfectly symmetrical, as it is, but not all graphs are going to be like this. So don't start copying what numbers are on the left hand side. So you pick the middle point, which is here, and you think, all right, 1690, 16910, and then 961, so the next carries on, it repeats itself. That usually is the case, but it's not necessarily going to peak in the middle. Sometimes it might peak on the more on the left hand side, sometimes it might peak more on the right hand side. So these are little things that you may notice, but try not to get too overconfident of thinking of easy ways to have done this, because like I said, in some cases you might get found out when it comes to other questions. Now you can also do this on a calculator. So let's say, for argument's sake, that we weren't given any of these values. So let me show you how we can enter this on the calculator. Now typing in these numbers on your calculator, again, I personally, to save time, if it was just the odd two values, is I would set up your formula. So here we've got 10, so I've got 10 minus, and then I'm going to put a bracket around wherever, anything that's got an x in, and then I swap that x with whichever number I'm looking at. So if I try 2, I'm going to type 2 and then square that value and then press equals, you can see it correctly gives me 6. And I'm going to correctly just do that, 10 minus, let's go for bracket 3 squared, and again get correctly gives me 1. And if I moved on to, now this usually works best when it comes to negative values, so 10 minus and then bracket minus 3 squared, and that should give me 1, which it does, and there you go. Now one thing you might want to do is, if you use the scroll button, rather than constantly entering the question, you kind of be a little bit smart and change just the digits and then press equals, and that should give me 6, which it does, and that's absolutely fine. Now there is also, if you're not comfortable with working with table of values and it is on a calculator paper, there is a setting on your calculator that can create the table of values for you. Now to do that, on this particular calculator, we press shift and mode we actually just press mode we press mode setup. Now the one we're looking for is the word table, so we select option 3. Now again, if I just go over what I've done there, just press mode setup and we're looking for table, so press option 3. Now fx is like your y, so all I'm going to do now is enter the equation that I want to plot, and the equation I want to enter is 10 minus x squared. So I do 10 minus, now to get the x I need to press the alpha, and then there's a little red x that you can just see on the calculator, and I need to have the squared. So what I've done there is I've entered the equation that I then need to plot. I then press equals. Now the starting value is the smallest x value I want to work out, which in this case is -3. Press equals. Now the end value is the biggest x value I want, which is 3. Press equals. And the step is basically what's the difference between all your x values. Well, the difference between all my x values in this case is 1, and usually will always be 1. So press equals. And lo and behold, what you've got is your table of values already done on your calculator. So here the x values are my x ordinates and the fx are my y ordinates. So as you can see, when x is -3, my fx value is 1. When x is -2, I get 6. When x is -1, I get 9. When x is 0, I get 10, and so forth. And so it's that my calculator can do the table of values for me. So if I'm not confident in manually entering values, as long as I remember how to do this on my calculator, obviously hoping that it is on a calculated paper, because obviously you've got no chance of doing this on a non-calculated paper, that's another alternative. Now obviously when you press equals, this fx tends to come up, so to get rid of that and to go back to be able to do normal calculations, just press mode setup again and select option 1 comp, and that will reset your calculator. So that's like another way of you doing that. Now from this, what we've then got is our coordinates, so the coordinates I need to plot. Now again, looking at, let's just get rid of some of these highlighted. So I know straight away from this that it's going to be a U-shape. Now the question is, if I need to manually draw my graph, then what am I going to have as my axis scale? So going on the x, now the smallest x value I've got is -3, so I'm going to have -3, and the biggest value is going to be 3. Now my y ordinates again are all positive, so the smallest one is 0, so I'm going to start at 0. The smallest y value is 1, and the biggest y value is 10. But again, I'm just going to go a little bit extra and go 11. So if you were to plot this graph accurately and to actually draw it, which is basically what the question is asking us to do, then that is the scale that I would be using. So plotting this, you can see that if I just plot my coordinates of what I should have, so at -3 it's at 1, at 2 it's at 6, at 1 it's at 9, at 0 it's at 10, and so forth. So you can see that straight away from my dots you can see that U-shape forming. And again, if I made a mistake, or let's say I changed that, let's say when I worked out -2 I wrote down, let's say 5, then that point would be at -2, 5 would be here, and you can see there that it doesn't quite fall in line. So for example, if I was to join those points up, it just looks a bit out of place. So this is why it's really important that you check your values, and drawing a graph will hopefully identify any mistakes drawn in your plotting. So again, just to go over, make sure that your graph is, so coordinates are correct, form to make a U or an N. I've noticed I've said that the opposite way around. 2, that you join the points up with a curve, not straight lines. And 3 is that your labelling of axes is done. Labelling of axes and equal spaces between the numbers. And then your graph should be perfect. So moving on to question 3. Now the main difference with question 3 is the fact that I haven't been given a table of values, so it's asking me to draw a table of values using the values where x is between and equaling -3 to 3. Now before I do that, I want to look at the equation that I'm actually plotting. You can see here that I've got quite a complicated quadratic equation to plot. Now the first thing I want to note is the fact that it is quadratic, because my highest power of x is x squared, and I also know that it's going to be a U-shape. Now when drawing a table of values, this is what we actually need to do, and what this is basically telling me is that my range of x values, so the range of x values is between -3 to +3. So if I go about drawing my table of values, and this one. Don't know why I'm going for green. Let's go for black. And let's just draw a line straight through that. And I'll do the rest freehand. So from this, I've got my x values, and I've got my y values. I'm going to start from -3 and kind of got a bit over, but that's not a problem. So that's my table of values drawn. Now if I write down the formula, which is y equals x squared plus 2x minus 1, again, encourage the use of putting brackets around everything that's got an x. Now if I was to work out this value here, then what I'm going to do is I'm going to replace the brackets with the number that I've got above it. So here I'm going to have -3 squared plus 2 lots of -3 take away 1. Now if I work this out either on a calculator, if it's on a calculator I would enter this exactly how it is. If I'm doing it by non-calculator method, I'm doing it sort of mentally, then I just need, it makes it a lot easier for me to break this up. So -3 squared is 9. +2 times -3 is -6. Take away 1. And if I work that out, I've got 9 take away 6, which is 3, take away 1, which is 2. So the correct number there is 2. If I work out this one here, I'm going to have -2 squared plus 2 minus 2 take away 1. So -2 squared is 4. 2 times -2 is -4. Take away 1, so we get an answer of -1. And then if I then move on to my next element, which I'll do up here, let's go rid of that. So here I've got -1 squared plus 2 lots of -1 take away 1. So -1 squared is 1, -2 minus 1, which gives me 1 take away 2 is -1. That gives me -2. And then I've got 0 squared plus 2 lots of 0 take away 1, which is -1. And then going from this one here, I've got 1 squared plus 2 times 1, which is 2, take away 1, so that's 1, plus 2, which is 3, take away 1, which is 2. And then for this one, let's do use different colour, I've got 2 squared plus 2 times 2, take away 1, so I've got 4 plus 4, take away 1, which is 7. And then finally for the third one, I'm going to have 3 squared plus 2 times 3, which is, let's do it that way, take away 1, so we've got 9 plus 6, take away 1, which is 15, 14. So there is my table of values. Now I'm not too sure whether I've done this correct. The only way I can do that is if I actually go on and plot it. So again, what I'm going to do is convert these into coordinates, and then we go about plotting it. So I'm going to plot -3, 2, -2, -1, -1, -2, 0, -1, 1, 2, 2, 7, and 3, 14. The key thing we need to note with regards to this is what set of axes are we actually going to use. So for this, I'm looking at the longest. So if I draw, just do a quick sketch. So again, I'm going from values of -3 to +3. Now the smallest y value I've got is -1, and the largest y value I've got is 14. So generally speaking, there are the axes I'm going to go for. Now personally, what I would do is I'd always go a couple of extra. So rather than using -1, I'll go -2, and rather than going 3, I'll go 4 and -4, just so that you've got a little bit of freedom. And the reason for that is that the minimum point of your quadratic curve is making sure that you include that, and I'll talk about that when we have a look at the graph for this. So again, as you can see, we've got our U shape and the coordinates are perfectly pointed. So for example here, from -3 we've got our values of 2, from -2 we've got -1, and these are the points that we should be having plotted on our chart here. So you can see, although it's not a perfect symmetrical set of points that we've got, you can see it does give me that point. And the most important bit is including that dip in your graph. And again, you also need to make sure that you're joining those points up with a smooth curve. And again, making sure that you are labeling your axes as well. So let's have a look at the next question. So again, here we're going to still go through the common theme of having to draw our own table of values, but this time our equation is just a little bit more complicated. And the reason why is because we've got 2x squared rather than a single x squared. Now for this, again, if I draw my table of values, I've got x and y, and let's just see how neatly, not very neat. So I've got -3, -2, -1, 0, 1, 2, and 3. Now the equation is y equals 2, and I'm going to put bracket x squared -3 bracket x. So again, if I'm going to do this on my calculator, I'm just going to swap whatever's in the bracket with the numbers that are in the table that I need to work out the y ordinates for. So if I just do a couple of these, I won't do all of them because it'll just get a little bit boring. So here I've got 2 times -3 squared, take away 3 minus 3. Now the key thing to remember is that 2x squared means 2 times x squared. So when we are doing that calculation, now I know that -3 squared, I've got to do that bit first, which is 9. So I've got 2 times 9, which is 18, minus, then I've got -3 times -3, which is +9. So here I'm going to end up with 27. And again, I can then carry forward. Now again, just a little reminder of how we can do this on a calculator. You can either enter the numbers manually, so if I was going to do this one here, it would be 2 minus 1 squared minus 3 lots of -1. So again, -1 squared is 1, times 2 is 2, and then I've got -3 times -1, which is +3, and that then becomes 5. And if I do one more value, let's do this one here. I've got 2 times 2 squared plus, and then I've got, no, it should be a minus, -3 lots of 2. So here I've got 2 squared, which is 4, times 2, which is 8, and I've got -3 times 2, which is -6, giving me an answer of 2. So again, all I then need to do is fill in the rest of that table, and again, let's use our calculator and I can show you how we can do that again. I can either enter the formula as it is, so for example, if I add brackets, no it isn't, I've got 2, and then bracket, let's do the -2, so it's -2, close bracket, squared, -3 bracket, -2, close bracket, and press equals, so I get 14, which kind of goes implies, so I just get and add 14 to the table. But again, if I want to do my table of values on the calculator, then all I need to then do is press the table function, so press setup, press option 3 to the table. I'm going to enter the equation in, so I've got 2 alpha x squared, take away 3, then alpha close bracket x, press equals. I want my starting value to be -3 because that's the smallest x value I've got. Biggest x value is 3, going up in ones, press equal, and you can see there that if I just scroll down, I've got all my table of value points in, so I can just fill in the gaps. So I'll just move this to the side. So the ones I'm missing are, let's go up one more, are 0, -1, and 9. So 0, -1 and 9. So here I've got 0, -1 and 9. So again, what I now want to do is plot this. Now again, when we're plotting the equation for this, we need to make sure our scales are correct and always go a little bit extra. So with my x ordinates, although I've got -3, I'm going to include -4 to 4, and then my smallest y ordinate is -1, so I'm going to do my graph to -2, and the biggest y ordinate is 27. So it's a pretty big graph. So again, you want to make sure you're going up accordingly. So because you might want to use 1 squared equals 1, although you'd be using a full page. You might want to go up in 2s, and that's fine. But regardless of what scale you go for, the shape of the curve is going to be exactly the same. It's still going to be that perfect U shape. It might be a little bit flatter depending on what scale you've used. It might be a little bit narrower, but it should still be that nice smooth parabola that we should get. So let's have a look at what that should look like. So as you can see, I've gone up on my y-axis, going up in 2s just to make it a little bit easier, and you can see I've still got that perfect parabola. Now with this, the key thing we need to know is that when you are joining the points, so if I just mark out what the points I should have got, so I've got minus 327, minus 2 point, minus 1, 0, 1, 2, and 3. Now with this, the minimum point or the bottom point isn't quite connected, and it's going to be quite difficult to see. Now you don't automatically assume that your smallest y ordinate is going to be the peak or the bottom, the lowest point of your parabola. It might not be the case. So it's always worth just joining the points up and experiencing where that peak is going to be and just smooth off the edges. And that's a key thing to look out for. So finishing up, let's have a look at some important things to note. So first thing to note is it's really useful to know what your graph is meant to look like before you start drawing it. So in all of this, recognizing that it's quadratic, recognizing whether it's a positive or a negative or a happy face or a sad face. Make sure your axes are drawn correctly and labelled and numbers are equally spaced on the axes, and again you will get marks for doing this correctly, so make sure you're not sort of rinsing time and doing that part quickly. Your parabola needs to be a smooth continuous U shape or an N shape, so making sure that's the case. And again, it's very easy to spot a mistake when you start plotting and a point stands out. Now going back to what your points should not look like, again, don't join your points up with straight lines. Make sure that if you have got a point where you've got like a flat bottom, it doesn't look like that basically. So what we need to then do is add an extra curve between those 2 points to give it that perfect U shape. So make sure you haven't got like a flat bottom. And again, make sure that if you have a graph that when you plot it looks something that looks like this, then to rectify that you've clearly made a mistake and that a coordinate is probably been miscalculated. And again, the fifth final point is make sure you accurately work out the y ordinates, but don't rush it. Work things out separately if needed, and you may find some y ordinates repeat, which is a common theme because obviously it goes up and then it goes down, or it goes up and then goes down. So it's key things to look out for. And also don't think that it automatically peaks in the middle of your x ordinates, because sometimes it won't.